Well, good afternoon, everyone, and welcome to today's live astronomy program. My name is Justin. Happy to be your guide today, and happy you're watching. If it's your first time tuning in, welcome to the show. We've got, by my count, 16 additional episodes archived for you right here on Facebook if you want to go back and catch up. But you don't have to have seen those previous episodes to enjoy today's show. If you have watched some of those previous episodes, welcome back. A few ground rules before we get started, or just things you should know. As always, need to thank our sponsor for this series, Allianz Partners. Happy to have them on board. For most of the rest of the show, we're going to be using software very similar to what we use in the Dome here at the museum. Actually using Digistar 7 for this show. Getting Digistar 6 all updated for you right here at the museum. Hope to have you back in the Dome soon. Now, just like the show on the screen here at the museum can be pretty impressive, today's show will still be just a little bit better if you are able to watch it on a nice big monitor. At least make the video full screen if you are able. And of course, the museum has reopened. Should have some people around the building today. Not quite ready to have you back in the Dome. I've still got some things to get ready for you in the theater. And this week, I've been updating a lot of the information that goes into the shows you see in the theater. And well, I thought it was a great opportunity to make that our show during this segment as well. So I am going to get us switched over to the main show, and I'm going to focus on the solar system today. I'm going to show you some of the things that, well, may have missed over the last almost 6 months or so. Yeah, it was back in mid-March when we had to close the museum. So it's almost exactly 6 months now. A lot can happen in 6 months. For example, there's our Earth there. Probably recognize that. I'm just going to zoom out here a little bit, and should have started us in March, and I'm just going to move time forward to the present day. So you can see just how much has changed all around the solar system. That's probably good enough for now. There's the inner solar system. All right, setting things in motion. So the first dot on the right is where Earth started back in mid-March, and when things stop moving, we'll be at the present day, and we've made it 6 months, basically halfway around the sun in Earth's orbit. So so a lot has happened, and I've got a lot to catch you up on. There have been lots of interesting discoveries in the solar system, of course. A few comets dove into the inner solar system. We got to see at least one of those in the skies without too much trouble, Comet Neowise. That was pretty interesting. But I thought I'd focus on our exploration of the solar system. We'll see what some of these spacecraft have been up to. That's what all of these markers are that have appeared on your screen, yeah, we'll use a few of those to help us measure the time that we've had between the last show in the Dome and hopefully the next one coming up soon. Now, I did a little bit of math along with everything else I had to do to get these spacecraft updated, and I found out that since mid-March, since the museum had to close for COVID-19, it works out to, well, let's see, about 248,670 minutes. That's a lot. Like a lot of the big numbers I use during the shows here, that's kind of hard to make a lot of sense of. How should we really measure that amount of time? Daylights, sunsets, I don't know. Well, you tuned into today's show, so we'll probably track it down using various milestones in these space missions. So, I mean, you see the little fleet headed to Mars. That was launched during the closure, so we've been tracking that during these online shows. A little bit closer to home, we've got spacecraft exploring the moon, and I thought I'd start with the spacecraft closest to us on this map. That circle closest to Earth belongs to the TESS spacecraft. That is one that pretty near and dear to me. I was at that launch a couple of years ago. It was a pretty good way to, it's supposed to coincide with my birthday. There's a delay, but that's another story. Still a pretty good way to mark my birthday, but a couple of years ago, 20 2018. So let's see what TESS has been up to since March. All right, so let's just head to the spacecraft here. TESS is in kind of a unique orbit around the Earth. It completes an orbit in just about 2 weeks, just under 2 weeks, so that it is kind of in sync with the Moon. It's a resonant orbit, like we've seen before out in the Kuiper Belt with objects like Pluto and Neptune. They share a relationship. So so TESS and the Moon are in a similar kind of resonance, and that makes TESS's orbit very stable, just like the orbit of Pluto is very stable out in the Kuiper Belt. Now, TESS is out here looking for planets going around other stars. It does that with the help of these 4 big cameras that you can see here on this side of the spacecraft. And what it does is every 27 days or so is it points to a new patch of sky. So in the background there, behind the spacecraft, we've got multicolored stripes going across the sky. Each one, that is either red, green, or blue, is a different section of the sky that TESS stared at for that about 27-day period. Back in the spring, it was looking in the northern half of the sky. I've got 1, 2, 3, 4, 5 different slices of the sky up here. So it's tracking these, and then it actually finished its prime mission over the summer. The spacecraft was launched back in 2018. Its original mission was to scan the sky over the course of 2 years, searching for exoplanets. So it looked for a bunch of exoplanets in the northern half of the sky earlier this year. It then completed its prime mission and switched back to the southern half of the sky. So here are even more multicolored stripes going across the sky. More places that TESS has been looking for exoplanets. Now, most of what you're seeing is actually individual markers for individual stars that TESS monitors every 2 minutes. So that means since we had to close the museum, TESS has taken at least 124,335 measurements of star brightnesses. Well, that's for each of those 20,000 stars in each of those sections. Those numbers are way too big. Still not a good way to measure the time that we had to wait to reopen the museum. How about its discoveries? So TESS is watching for transits. We've talked about that a couple of times in previous episodes, and TESS has used those transits to make a decent number of discoveries. Let's get rid of all of those individual stars, and let me just show you the planets that TESS has discovered. As of March, its discovery total was in the neighborhood of 40. I haven't counted all those circles, but each one of the circles on your screen now is a single planet detected by the TESS spacecraft. Now, I have counted these up. Every planet it's discovered in the last 6 months. I'm going to add in I think yellow is the color these will appear in. There are 28 of those. So yeah, we've added 28 brand new planets from the TESS spacecraft in the last 6 months. Pretty good. But of course, TESS isn't the only spacecraft or the only telescope that helps us find new planets around other stars. Altogether, in the last 6 months, we've crossed the 4,300 exoplanet mark. 171 planets have been added to our total in the last 6 months. So those are being added in orange to your screen. So our map of other planetary systems has changed quite a bit in the last few months. Definitely wanted to have the most up-to-date information for you when I welcome you back to the dome. So you've got that to look forward to. All right, let's check out what's been going on throughout the rest of our solar system as well. TESS is looking at planets far away. That's pretty close to the Earth. Let's check out at least one other planet in the solar system. I mentioned those spacecraft that are on their way to Mars right now, but they won't arrive until next February. So we'll be able to track that in the dome, no problem. Let's see. Let's head out to Jupiter and let's see what a spacecraft out there has been doing. Jupiter is the home of the Juno mission. It's been out here for, well, about 4 years now. So it has had plenty of opportunities to make some interesting discoveries. We've tracked it pretty regularly in previous shows in the dome, and looking forward to tracking the next phase of its mission over the next few months and hopefully the next few years. So here is Juno as it is right now. This should be its accurate position. I don't actually see Jupiter right now, though. Let me see if I can track that down. As we speak, Juno is not especially close to Jupiter, but it's getting closer. You might notice there's one kind of crescent-shaped object on your screen now. That is the planet Jupiter, and Juno is currently getting closer and closer to it. Juno's orbit around Jupiter takes it almost 53 days. So the last 6 months or so, the last 248,670 minutes, that is about 3¼ orbits of Juno around Jupiter. And it turns out it's going to complete an orbit a little later on this month. In just about 2 weeks, Juno will experience something called perigove. That's when it makes its closest approach to Juno, end of one orbit, beginning of the next orbit, and the next one is coming up on September 16th. That's just next week. So you can see Juno getting closer to Jupiter here. If I swing around, you'll actually be able to see Jupiter up close and personal. That's what Juno does. At the start of every orbit, it makes these close passages just a couple thousand miles above Jupiter's cloud tops. This allows Juno to make detailed measurements of Jupiter's magnetic field and its gravitational field. This is helping planetary scientists reconstruct what the interior of the planet is like. We know that the outermost layers of Jupiter, its a very thick atmosphere, are a mixture of different gases, mostly hydrogen and helium. We've got some water, ammonia, gases like that as well. But we want to really understand the inside of Jupiter as well. So that's why Juno is here. Talked about that way back in our second episode. So you can see a little bit more about Juno's mission here if you go back to our video archives. Since I'm just looking back at the last few months and getting ready for future shows, I thought I would also get ready for the distant future. So Juno has been here for over 4 years now. It arrived in July of 2016. And so over that time, it has completed a couple dozen orbits of Jupiter. This will be its 29th orbit that it completes next week. So here are all of Juno's orbits around Jupiter. I just like having north up, so I'm going to rotate us around here. It doesn't really matter that much in space, but it'll make a little more sense for the picture I'm about to put up there. So here is where Juno has been over the last 4 years. Its orbit shifts a little bit, but generally it makes its closest approach to Jupiter more on the daylight side of the planet, and then it retreats to the distant reaches on the nighttime side of Jupiter. Now, if all goes according to plan, if nothing changes, I guess I should say, the Juno mission is actually starting to wind down. This will be orbit 29, and it's only scheduled to complete 35 orbits around Jupiter. So this would be all that Juno has left. Under the current plan, the spacecraft will actually plunge into Jupiter's atmosphere at the end of next July 2021. But that may not be how the mission ends. There is currently a proposal under consideration, or at least about to be submitted, that would extend the Juno mission, and it gives some pretty interesting opportunities. Let's zoom in here a little bit. So those orange lines are the orbit of Juno around Jupiter, and you can see how they are already pretty close to this gray orbit going around Jupiter. That is one of Jupiter's moons. It is Ganymede. Now, Juno has already collected some interesting images of Ganymede. In fact, they are the first images of Ganymede's polar regions. I know this picture isn't super sharp. It is also an infrared light, and that's still useful, even though it's outside our visible range. Go back a few episodes, we talked all about the electromagnetic spectrum. There are interesting things that infrared light can show us, so these are still historic images. And if Juno's mission gets extended, it would have additional opportunities to fly by some of these moons of Jupiter. So as a very rough schematic of what the rest of the Juno mission might look like if it does get extended. So the gray orbits would be what it has already done. Has already done, and then the blues and purples there would be what it would do in its more extended mission. There'd be 3 phases where we get up close looks at 3 additional moons. We'd see Ganymede up close a couple more times. It would do some flybys of Europa, which would be especially useful. We talked about that a little bit last week. There are 2 more missions headed to Jupiter in the next decade or so that will target Europa specifically. And then Juno would also get a chance to fly by Io a couple of times. Talked about that last week too, because Io is very volcanically active. And Juno's infrared cameras are ideal for tracking volcanic activity on Io. So this proposal is going to be submitted by the end of this month, and hopefully NASA will make a decision on it by the end of the year. So in the next couple of months, I'll be able to tell you how long the Juno mission is going to last. And hopefully we're looking forward to a lot of flybys of some of these other moons. Should be pretty exciting. All right, so we could track our passage of time here by how the Juno mission is doing. Every 53 days, another orbit. But the classic way to tell time is to keep an eye on the sun. So let's check out the sun as well. There it is, off in the center of the solar system. We have a couple of spacecraft that are exploring the sun right now. I've mentioned them a couple of times over the course of the summer. The 2 most prominent spacecraft exploring the sun right now are probably the Parker Solar Probe and the Solar Orbiter spacecraft. So I've got the Parker Solar Probe closest to us at the moment. This would be its current position, not shown to scale here. It's much smaller than the sun, but there's its location in orbit around the sun right now. And then around the solar system this way, we've got the Solar Orbiter spacecraft. Solar Orbiter, a little bit newer. It was just launched earlier this year, back in February. And a few weeks ago, we took a look at its very first images of the sun. So it's out here doing cool science already. But this is the current position of these spacecraft. Let me show you how things have changed over the last 6 months. I'm going to get a nice bird's eye view for us. Zoom out just a little bit. So again, this is current locations of these spacecraft. I'm just going to rewind here a little bit. The kind of pink colored trail is Solar Orbiter. The more goldenrod colored trail is Parker Solar Probe. So in the last 6 months, Solar Orbiter completed most of an orbit. Its orbital period right now is about 7 months. That's going to change. But Parker Solar Probe made it a little more than halfway around, and its path really changed quite a lot. So I'm going to zoom in a little bit over here, and we're going to run time forward, and I would encourage you to watch Parker Solar Probe carefully. All right, so that's the one following that orange trail, big spacecraft up at the top of your screen. Okay, here we go. Keep an eye on the Parker Solar Probe. Well, let's run time forward. Get those spacecraft orbiting the sun again. So that's where it was in March. It dives in towards the sun. Parker made a close approach to the sun called perihelion back in June. And then it came out here and made a close flyby of Venus. And it was that flyby of Venus that altered Parker's path around the sun. Actually allows the spacecraft to get even closer to the sun. In the coming months and years, we're going to be keeping a close eye on the Parker Solar Probe because it is going to be getting progressively closer and closer to the sun. as you can see there at the center of the solar system. It's flying into the sun's extended atmosphere, the corona. It is measuring what conditions are like in the corona. It's helping us better understand how the solar wind forms. These are charged particles that stream off of the sun all the time, interact with all the other worlds in the solar system. Here on Earth, you might know about the aurorae, the northern and southern lights. Those occur because of the solar wind. These charged particles stream away from the sun, get trapped in the Earth's magnetic field, spiraling towards our atmosphere. So we need to know about the solar wind, and Parker Solar Probe is helping us decode that. So that'll be worth watching. Also worth watching is the Solar Orbiter spacecraft. We're looking far into the future now. This is probably a couple of years into the future, but you can see that its orbit is changing. Those red lines are now changing their angle or their inclination compared to the plane of the planets in the solar system. On the left side, Solar Orbiter is rising higher and higher above the planets. It's dipping down a little bit below the planets on the right-hand side. Solar Orbiter is going to be able to do this thanks to multiple flybys of the Earth and multiple flybys of Venus. So as it does this, it won't get quite as close to the sun as Parker Solar Probe does, but it will allow Solar Orbiter to see the poles of the sun for the first time ever. So we saw its very first images a few weeks ago. Those were similar to views of the sun we can get with other spacecraft and telescopes here on Earth. But in just a few years, the Solar Orbiter will be returning unique images unlike anything we've ever seen before. We'll see the poles of the sun for the very first time. Should be pretty cool, but it's not going to happen until 2025. Now, speaking of things that'll take a few years to take place, another mission that is pretty close to my heart, the OSIRIS-REx spacecraft is going to be returning to Earth with a sample from asteroid Bennu in a few years, 2023. And it's been doing some pretty cool stuff throughout the summer. So let's take a look. I need to make sure we can fly over to, let's just make a quick correction here. Sorry about that. I gotta make sure we can fly over to the asteroids. So I'm gonna jump to OSIRIS-REx right now. I've shown you a few images from OSIRIS-REx over the last few weeks and months because what it is getting ready to do. OSIRIS-REx has been in orbit around the asteroid Bennu for about a year and a half now, and is preparing to descend all the way down to the surface of the asteroid and collect a sample. And that's something you don't just do without any practice. So most of the last 6 months for OSIRIS-REx and the scientists working on the mission have been spent practicing for the actual collection of a sample from the surface of the asteroid. And well, I thought I'd just replay the entire last 6 months of this mission. So let's see. This should be March. So let's fast forward to see what OSIRIS-REx has been up to. So this is end of the day, March 13th, and let's see what has happened over the last 6 months. So if you would like to try and count along with me, I'm going to see how many times OSIRIS-REx has orbited Bennu. No, I've lost count. It was about 120. But I want to bring special attention to the couple of times when this blue line is the trajectory of the spacecraft around the asteroid departs from the circular paths, its orbit around the asteroid, and approaches the surface of Bennu. Those were 2 touchdown rehearsals taking place over the last few months. The most recent one was about a month ago, which is at the beginning of August. Now, during these close approaches, OSIRIS-REx has gotten especially detailed imagery of its sample site, and they've also been able to test brand new software that had to be written over the last few months to make sure the spacecraft could navigate itself. The surface of Bennu proved to be much more rocky, covered in huge boulders than they were originally planning on. So they had to totally change their plan for getting down to the surface and collecting a sample. So these rehearsals have been critical to making sure the spacecraft can execute the sample collection correctly. That is scheduled to take place now at the end of October. So stay tuned for that. On the last rehearsal, although they purposefully did not go all the way down to the surface of the asteroid, the software predicted that it would have successfully collected a sample. So seems that the rehearsal was a success. Hopefully they'll be successful again in October, and then the spacecraft will eventually depart the asteroid, bring that sample back home. But they do need to collect some more data here at Bennu. There are more things to study. In addition to finding the surface of the asteroid was surprisingly rocky, they have found some strange activity here at Bennu. When they designed the OSIRIS-REx mission and they sent it off to Bennu, expected that the spacecraft would be alone in orbit around the asteroid. But perhaps the most amazing thing that the spacecraft has discovered is that this is an active asteroid. From time to time, something happens on the surface of Bennu that causes particles to be ejected into space. This video was just released by NASA yesterday, part of analysis of imagery that was collected over the last couple of years, and they're trying to recreate the trajectories of these little bits of rock that have been spotted in images by OSIRIS-REx. And what appears to happen is that as the asteroid rotates, one day on Bennu is a little over 4 hours, the rocks on the surface, those big boulders, undergo a lot of stress because the temperature is constantly changing. And from time to time, that stress from warming up and cooling down every day and night gets to the rocks, they break apart, they fracture. And when they break apart, it seems to release some particles, and sometimes those particles are ejected into space. Sometimes some of those particles end up in orbit around Bennu, so it's been a pretty surprising feature of this asteroid that may apply on various other asteroids around the solar system. So OSIRIS-REx keeping a close eye on that along the way to collecting a sample and returning it to Earth as well. So those are just what a few of the spacecraft exploring our solar system have been up to over the last few months. I've got all that updated data now. I'm working on bringing some of those rocky particle trajectories to the Bennu asteroid too. Those will be fun to fly around with in the dome, but needs just a little more work. I thought to end the show today, I would do one more thing. I showed you all of those spacecraft. Most of them that you're easily able to see on your screen were somewhere in the inner solar system. Let's see if we can make those reappear on the screen for you. So we've got various spacecraft exploring the inner planets. We've got the ones orbiting the sun. We've got spacecraft at the moon. We've got spacecraft at Mars. We've got that small fleet of spacecraft on the way to Mars. Even showed you Juno there, just beyond the asteroid belt. So that's most of our spacecraft that are exploring the solar system. There are a few that I have left out. Some of our spacecraft are so far from the sun they don't easily fit on the screen. You might see them off in the distance there. I'm going to try and get them more conveniently located so we can see what they are. They're all spacecraft that I've talked about a time or two during the course of our shows over the last few months. This one here on the outer edge of the Kuiper Belt, you might be able to read that label. That is New Horizons. Of course, flew by Pluto about 5 years ago, and then flew by another little Kuiper Belt object about 1.5 years ago. And then we have the Voyager spacecraft, recently celebrating their 43rd launch anniversaries. It's going to be pretty tough to zero in on, but at the top of your screen we've got Voyager 1, Voyager 2 down below. So these spacecraft are pretty far away, and they are moving pretty fast. In fact, they are moving fast enough that the sun's gravity will never be able to slow them down enough to pull them back into the solar system. Voyager 1, Voyager 2, New Horizons, they are all going to escape the solar system entirely. one day. Voyager 1 and 2 have already kind of exited the sun's extended atmosphere. They are beyond the limits of the solar wind, but they've got a little farther to go before they leave the solar system. We covered that in an ancient episode of this series as well. But when these things are so far from the sun, as the distances get so big, it's kind of hard to make sense of how far they are going. So I thought, as one last little experiment, a little bit of number crunching, I would show you how far these distant spacecraft have traveled in the last 6 months, but put them in a context that, well, might make slightly more sense. So we're going to go into an imaginary version of the solar system here, and I'm going to zoom in on the sun. I've taken all of those spacecraft away from their current positions. They're no longer in the outer reaches of the solar system. They are now right next to the sun. I've got them all lined up there because we are going to have a little race. I looked it all up. I determined where these spacecraft were in mid-March, and I determined where they are today. And that's a pretty simple matter to do some subtraction and see how far they have gone in the last 6 months. So I'm going to start them from the sun here, and let's just have a little race between these three extremely distant spacecraft and see how fast they're going, how far they've traveled over the last 3 months. We'll start the race in 3, 2, 1, go! And there they go. All right, so these spacecraft traveling pretty quickly. I know it doesn't look extremely fast on your screen, but they are traveling much faster than any other spacecraft that are in orbit around the sun. That's how they're able to escape the sun's gravity. In the last 6 months, all three of them, if they had started at the sun, would have crossed the orbits of Mercury, Venus, Earth, and New Horizons would have just gotten to Mars's current location. Now, the distance between the sun and Mars changes a bit throughout the year, but New Horizons just about at the current location of Mars. In 6 months, New Horizons has gotten from the sun to Mars. It is taking the spacecraft we launched from Earth longer to get between Earth's orbit and Mars. So New Horizons moving pretty fast. Voyager 2 going a little bit faster, so it makes it a little bit farther. Out of these three spacecraft, Voyager 1 is the fastest. It has traveled the fastest in the last 6 months. It wins my little race today. So there you go. That is what has been going on in the solar system today. A lot of exciting exploration, a lot of interesting things to look forward to in the coming months, and a lot of interesting things that have happened over the last 6 months. So I've got all this data now. I'm going to go put it on computers up in the dome and look forward to having you back in the theater very soon. In the meantime, the museum's open. You can come on by and check out the exhibits. Be sure to check the website for the experiences that are currently open to you. We have various guidelines to keep you safe here as well. So until next week, I want to thank you for tuning in, and hope you enjoyed the show, and I hope you enjoy the rest of your day.